are going to be laying out Hyperscale Datacenter using Revit. And right now we're going through the NVIDIA AI factory for the new Industrial Revolution presentation. What you see is the Blackwell, the largest chip physically possible. 104 billion transistors, TSMC4 NP process, 10 terabytes NVIDIA high bandwidth interface. Blackwell GPU, the two largest dies possible, unified as one GPU, 208 billion transistors, full cache coherency. Blackwell versus Hopper, twice the size, a massive leap in compute, 128 billion more transistors, 5 times the AI performance, 4 times the one die AI memory. Blackwell, the engine of the new Industrial Revolution, 20 petaflops of AI performance, 192 gigabytes of HBM3E, 8 terabytes of memory bandwidth, full stack CUDA enabled. Two Blackwell GPUs and one Grace CPU, building blocks of the GP200 superchip, 384 gigabytes of HBM3E, 72 ARM Neoverse V2 CPU cores, 900 gigabytes of NVIDIA Link C2C bandwidth. GB200 Grace Blackwell superchip, processor for trillion parameter scale generative AI, 40 petaflops of AI performance, 864 gigabytes of fast memory, 16 terabytes of HBM, 3.6 terabytes of NVIDIA Link bandwidth. Blackwell compute node, most powerful compute node ever created. 2 Grace CPUs and 4 Blackwell GPUs, 8 petaflops of AI performance, 1.7 terabytes of HBM3E, 32 terabytes of memory bandwidth, liquid-cooled MGX design. Connect 800G NVIDIA band Super NIC, industry most advanced GPU RDMA adaptive routing and programmable congestion control optimized for AI processing. We're going through this. This is absolutely phenomenal. What I don't see here is the components within each blade to cool it down. This is something that maybe this presentation is showing that I'm not picking up. Now, what we're going to be doing is using this composite, this presentation, to design hyperscale data centers. We're laying out the HVAC system as well as the cooling aisles and the liquid cooling underneath the raised flooring. Bluefield 3 DPU, powerful infrastructure processor, line speed processing of networking, storage and cybersecurity, and network computing, 80 gigabytes of memory bandwidth. Wow! GB200 NVL72, compute for the modern data center, 18 compute trays and a rack. 18 compute trays, that's interesting. 36 Grace CPUs and 72 Blackwell GPUs. The amount of heat that these bad boys produce has to be intense. And what I'm interested in is, does NVIDIA have cooling? Onboard cooling systems. NVIDIA Link switch, Blackwell, multi-GPU fabric, 2 NVIDIA Link switch chips, 8 ports at 1.8 terabytes, 14.4 terabytes of aggregate bandwidth. NVIDIA Link switch system, Blackwell, multi-GPU fabric, 18 NVIDIA Link switch chips, 72 ports at 1.8 terabytes. All-to-all communications at 130 terabytes of aggregate bandwidth. GP200 compute nodes, NVIDIA Link switch and spine, 1 massive GPU for generative AI, 72 Blackwell GPUs fully connected by NVIDIA Link. Copper cabling for 3 times less cost. Blind mate connectors for easy installation and serviceability. GP200 NVL72 compute for trillion parameter scale generative AI, 1.4 exaflops. 1.4 exaflops of AI performance, 30 terabytes of HBM3E, 1 giant CUDA GPU. Amazing. Quantum InfiniBand switch, unparalleled data throughput and in density, 800 gigabytes of throughput per port, 230.4 terabytes of aggregated bidirectional throughput. Here's where it gets interesting. Quantum X800 InfiniBand or Spectrum X800 Ethernet switches, networking for the highest AI performance. 800 gigabytes connectivity, 5 times higher bandwidth capacity, 14.4 teraflops of in-network computing. So here what you see is the means for liquidly cooling down each rack. Now, each server rack. What I'm wondering is the internal components that connect the hot and cold piping to the actual blade or processes of the servers. That's what I'd like to see. GB200 NVL72 compute racks, liquid cooled for best energy efficiency. 8 GP200 NVL72s, 288 Grace CPUs, and 576 Blackwell GPUs. 2 times reduced rack cooling power. Full data center with 32,000 GPUs. Good Lord have mercy. AI factory for the new industrial revolution. 648 exaflops of AI performance, 13 PB of fast memory, 58 PBs of aggregate NVIDIA Link bandwidth, 16.4 petaflops of in-network computing. Everyone, this is an industrial revolution. This is an artificial intelligence revolution, an intelligence revolution. This is fathomable 30 years ago. What you see before you is cooling owls in between two sets of racks and then multiplied to 32,000 GPUs. The amount of power needed for this type of layout can be reduced when the means for cooling is extremely efficient or naturally procured. If you don't have to pay for cooling, the cost to run a data center becomes economical. Also, producing electricity for a data center does not necessarily have to be as financially intensive or cost intensive or so astronomical. There are, in my opinion, ways of cooling and powering a data center that is fundamentally designed for processing artificial intelligence. And what we're going to be doing is laying these hyperscale data centers, these AI factories, out in Revit. Extremely exciting. NVIDIA is doing amazing work. Welcome to the new industrial AI factory revolution.